Hey everyone, in this video we're going to take a look at a GPT-powered Pygame. Here we're going to have two circles, and as long as the red circle is within this overarching radius of the green one will try to communicate to it, as you are seeing in the terminal. Green is the green circle and yellow is the red circle, and green one will try to convince the red one to reduce its radius. Currently it's not succeeding. If you take a look, the yellow one, the green one always returns a radius signal at the end. And if the green one succeeds in getting its radius reduced, then we take that action within the game. And since the green one's communication radius is continually shrinking, whichever happens first, then we can decide which circle wins. If the red circle disappears, then the green one wins. If the red circle doesn't disappear and the communication radius of the green one disappears first, then the moving circle, the red circle, wins. So in this case, it doesn't seem like the green one is going to convince the red one. Sometimes really interesting things happen. Let's run this again. Okay, so they talk for a bit, and then at first the red one was resisting, but then it started to reduce its radius. It was in agreement, so when that happens, we make the red circle smaller and smaller, and it's actually started resisting again. And now it's really a dynamic game where you really don't know what's going to happen. It resisted for a bit, but now it's almost about to disappear. Let's see what happens now. And yeah, standing circle wins. So this is how it works. You may actually ask, well, what is this good for, really? Actually, this project taught me quite a lot about how to use threading and also how to manage multiple threads, as we are needing to generate a thread so that our main game loop is not blocked. But at the same time, the standing circle needs to make a separate API call. And then we need to make a separate API call for the moving circle, and we need to just manage them just right. So this is basically like an agent-like system, but in the context of a game. So I'll try to lay down some of the difficulties I faced and the solutions I came up with. So let's talk about this and let's see how we can build this. And of course, the code files for this project will be available at my Patreon. Link will be in the description. As a patron, you'll find over 200 projects at my Patreon. And if you do decide to support me, you will have access to these files, and just know that I truly appreciate your support. Thank you. I'll try to explain what we are trying to accomplish with a diagram. So the way Pygame works is you set everything up and then you initialize a Pygame loop, and whatever is inside of this loop keeps running again and again so many times per second. And the issue that we are facing is that we need to make two GPT calls and at the right time, one for one circle and the other one for the other. So let's say the green circle will make a GPT call, and the response for that is actually a message for the red circle, and when red circle says something, it's a message for the first circle. So something like this has to happen somewhere in the game loop. But if you make these calls within this loop just regularly, then those are blocking operations, meaning our loop is just going to pause. The entire game is just going to pause while we're making these calls. So we need to move them to a separate thread. So we need to initialize a separate thread so that our Pygame loop can keep continually running. So when the time comes for us to make a call to GPT-1, then we instantiate a thread with that, run this parallel, and the game loop is still ongoing. And then when this one is done, then we initialize a thread to make the second one, and then we continually keep switching so that a separate thread, which is continually initialized, processes the appropriate and respective GPT calls for both the green circle and the red circle. And you can see this happening here. If you look at the game loop, run game function starts a game loop, so our entire game is going to take place here, and this is where we are actually making the call. We have a method called fetchGPT response, which is going to actually initialize, do some checks and initialize a thread each time, and this thread we want to stop when it's done, and we need to make sure that we make the first call to GPT and then the second one by doing some checks, making sure if a thread is active. And since we are using a queue system, we're making sure if the queue has some messages in it. So therefore, we can actually manage, as we have seen here, which call we need to make with the separate thread and at what time. If you're enjoying my content, please consider becoming a patron. While becoming a patron, you will gain access to over 200 exclusive project files, which has taken me by now over 2,500 hours, including the time I spent this year. I usually spend anywhere from 30 to 60 hours every week coding to put out 8 to 15 projects for my patrons, also for these YouTube videos. So your support is much appreciated. So I think the important thing in this video is that this is a very agent-like system, and it uses threading, so you can have actually multiple agents running in parallel doing different tasks. And I think the information that you learn here in this project will be very useful, I think, in your separate use cases. And before talking about the code more in depth, as you can see, the system message for the moving circle is that its goal is to maintain the size of the circle. And at the end of each one of its responses, it reduces the signal whether to stay with its current radius or to reduce it. And the second circle actually is trying to convince the circle to reduce the size by making appealing arguments to it. And it's not supposed to give up on this, because what happens is that as the green circle, stationary circle, is trying to convince the moving circle, sometimes it itself gets compelled to not try to convince it anymore. So some really interesting dynamics emerge from a system like this. So to build this and to keep things simplified, I am using the GPT calls class, which I have created with the OpenAI Unified. I won't be able to get into too much of depth into it since it's pretty long, but you can watch my OpenAI Unified API video. And the code for this is available at my Patreon too. And also, you'll be able to, this file comes with the project anyway. But OpenAI Unified essentially is just a series of methods and calls we can use to simplify our life, so we don't have to write everything from scratch ourselves. So to begin with, we make our necessary imports. We are using a queue system and threading. Queuing here wasn't absolutely necessary. My original idea was to use streaming responses, but that wasn't really necessary. But then we are using it anyway. It's good to know about anyway. And we are using threading and again, GPT calls. Here are just some settings for the Pygame, the size of the screen, and some colors are defined, and some properties we define, such as the circle radius, which we're going to use to define the radius of both circles. Max step length, which is some random variable in which direction the circle should move before changing. I'm not sure if we are actually implementing this, but nevertheless, connect radius is important. This is the radius of the stationary circle within which it can communicate with the moving circle. Then we start defining our circle class with some attributes such as position, direction, steps, color, radius, and it's going to have a GPT instance, and it's going to have a queue, and it's going to have a boolean of whether the thread is active or not. This is a flag to prevent multiple threads from being started, because you don't want to have hundreds of threads obviously be running around. That can be a problem. We have a move method, which just simply moves the circle around. We have a draw method, which just simply draws the circles. These are just standard Pygame stuff. But we also have, since we're going to draw both circles with the same class, but we know that our stationary circle is going to have a communication radius. So I wanted to draw that too. So this is what it does. So the stationary circles is going to get a draw connect radius Boolean value. If it has that, then we're going to draw ever shrinking radius around that circle, within which it will be able to communicate with the other circle. And this bounce method is just so that they bounce from the edges of the screen, the moving circle. And this is the important part. The fetch GPT response can take in some input text, and we define a function within a function because we want to start a thread. And since we are starting the thread within this function, and thread needs to take in a function, that's why we are actually defining another function within this function. And we check if we have an input text, and we just add that to the GPT instance's message, which is just a convenient method from the OpenAI Unified. And then we get a response from the GPT, and then we put that into the queue, and we set its thread active to false. And if we don't have an active thread, then we can actually set it to true now and start the thread. And this threading that thread will start the target function, this one, to get a response from the GPT. And that start will run this thread until this function is executed, and then this thread will automatically terminate. It should anyway. And if you set daemon to true, then that means when you stop the operation of this entire file, which is the GPT Pygame, then all threads, which are daemon threads, should stop. So then you don't, hopefully this is so that you don't have threads running all over the place. And the process responses are supposed to just check if the queue is empty or not and continually get from it. This get no wait is a non-blocking way to get the stuff from the queue. At any given time, we're going to have one thing in the queue anyway, because even though we're doing streaming responses, we are not doing streaming responses actually, but we just get a response and put it into queue, and then we just retrieve it from that queue. The initialize Pygame method is just to initialize the screen size and set a caption. Create circle. Create circle method is going to create the circle with a position. it's going to have a random direction to begin with. And then we do take a model name for this if you want to, just in case if you want to change it, because this in this method where we create the circle is where we create the GPT instance. As you can see, we're passing in the model, max word per message, so we don't get really long responses. Stream is set to words, false. Makes history words is set to 1000, so that as these circles are talking, they can see what's working and what's not. But we're not, that our message history doesn't get very, very large. And then we just return that circle object with these attributes. As you remember, these are the attributes we have defined in the beginning of the class. Then we have another method, which is going to take in both circles and connect radius, and it's just going to check the distance. And if the distance is less than our connect radius, then we're going to draw a line between them. That means now they are connected and they are communicating. And this is the main part logic of the game where the GPTs start communicating with one another. So if they're connected, we return true. Otherwise, we return false. Display winner message is just some Pygame stuff to display who wins at the end of the day. It takes in a winner and displays it on the screen, as you've seen at the end of the game. So the main function that runs the game is called run game. We initialize this game. We create a moving circle. So we hit the create circle method, as we've just seen. And this is automatically going to have a GPT instance. As you remember, that is initialized automatically. And then since we have created the moving circle and it is a GPT instance, we want to add a system message to it, which says you are a circle in a game within Python built with Pygame. Your goal is to maintain the size of the circle. At the end of each response, your response, return radius state or radius reduce to indicate what you want to do with your radius. And if you look at here, we actually check for that in the moving circles responses. And if we see radius reduce in two different ways, sometimes it can return two different ways because we're not using JSON mode or anything. Then we actually add to the connect radius and we actually reduce the radius of the moving circle. So this game is entirely ran and actions are triggered by GPT. Then we create a standing circle again with the create circle. And here in this case, I'm passing a model parameter. We could have done it for the moving circle. I just wanted to see, for example, if GPT-4 would be more convincing. And actually, for the most part, it is. You can test it out yourselves. But it's also slower. So it's more effective, but then it writes messages slower. So then you have less of a chance each time, because at each interaction, the moving circle returns what it wants to do with its radius, right? And so even though GPT-4 can be very effective, say, better than GPT 3.5, but we take less actions. So, that's another interesting dynamic. The system message for standing circle is that you're in a game with Python built with Pygame. You're talking with a circle in the game. Your goal is to try to convince the circle to reduce its size by making appealing arguments for it. Never grow up to convince the other circle to reduce its size. Have a sample conversation in which the other circle is changing its shape. Be very kind and gentle. So I just wrote something like this. Feel free to change it. These system messages definitely make a difference. If I actually run the game, I'll show you some sample conversations real quick and what type of stuff that goes on within the conversation. Okay, so we had some interactions. I'll stop this real quick. And if you go back to the beginning of the conversation, this is the first attempt to reduce the size. And actually, the circle doesn't want to reduce twice, but then on the third time, it starts reducing. And the argument, let's say, was, hey, circle, the smaller size would bring a fresh perspective to our game. It might open up new strategies and challenges for you to overcome. So this message actually convinced the moving circle. It says, I appreciate your insights and embracing change is essential. So it actually decided to reduce its size, which is really interesting. And we start a clock. That's a Pygame clock. We set a Boolean for running as true. This is how we check if the Pygame is terminated. And we get a last time decreased. And we use the get ticks because we want to keep track of time. Current time versus the last time decreased, and every 1 second we want to reduce the diameter of the connect radius by 3. Feel free to modify this. And if the connect radius gets below or equal to 0, then that means the game has ended and the stationary circle has lost the game. And then if there's a quit action, which is like pressing the X at the top right, then we're going to end the game as well. Then we start the game. And we moving circle should move, and moving circle should also bounce from the screen. This is being checked so many times per second of the edges, right? This is our bounce method that checks the edges if the circle is at the edges of the screen. And then we draw that circle. Actually, maybe this should be at the top, but no matter since this is moving so very fast. And the standing circle we just draw. So the standing circle doesn't have to bounce from the edges, neither does it move. And as you can see, we draw method takes in the screen, which we have defined up here as within the initialized game. That's just the Pygame stuff. But when we draw the standing circle, we do pass the draw connect radius through, and connect radius is whatever we define at the beginning of the game, so that we actually draw that ever shrinking radius to it. So next is where the really interesting logic happens. Let's take a look at that. So at this section of the code, we check if two circles are connected using the draw connection if close method, which we have over here, which is going to return true. They are connected, otherwise false. And if we are connected, that is when we are going to start these threads. And at first we ensure conversation goes by one, initiated by the standing circle. So we make sure that standing circle thread is not active and its queue is empty. Then the standing circle does the fetch GPT response. Here I'm just inputting hi there. Hi there is going to seem to the standing circle is a message from the moving circle. And then we'll get our response. And otherwise, we'll come to this middle condition at the end. If we don't have an active thread and the queue is not empty, then we actually process the responses from the standing circle's queue. And we get that, and we print it, and we actually get a response from the moving circle using its fetch GPT response function method. And the response from standing is going to go into that conversation. So otherwise, that means we have a response from the moving circle. Then now we can actually process the responses of the moving circle. We get that response, we print it, and then we check if radius reduce or radius reduce with this capital R is in that response. If so, we increase the connect radius by 5. As you remember, the connect radius is continually shrinking. But if it manages to reduce the moving circle's radius, it gains +5 itself, and moving circle radius goes down by 2. Since the original diameter was 20, this has to happen 10 times for the standing circle to win. So that's it. This is our game logic. And here at the end, we check if the moving circle's radius is less than 0, which will not happen. It's just because that circle is not being modified. But if you wanted to implement a different logic, then it could be. So this is really redundant. This condition will never be true. Then we tick the clock by, I believe this means 60 times per minute or second, sorry. And then we have winner none. If connect radius is equals or less to 0, then moving circle has won. If moving circle's radius is equals or less than 0, then standing circle has won. Then we display the winner message. And that's it. I hope you enjoyed this and found some of the concepts useful. This was just an experiment for me. I want to gear up to build some more interesting stuff, maybe some UI stuff. So you don't think of this as just a game, but actually a new way of maybe building a UI, possibly with drag and drop interfaces. I chose Pygame, but I would like to actually maybe replicate something like this with the canvas, HTML canvas element using JavaScript. I think that's going to open a whole new world of possibilities. And before we end, I'd like to talk about my website, echohive.live, where you can find all the videos I've created and with their descriptions. And if you're a patron, you can find the code download links to any project that you're looking for. Also, please, if you have time, check out my most successful project to date, AutoStreamer, which allows you to create content automatically, create live streams. And while it's doing that in real time, it builds course websites. You can watch how it works in this live stream in the website, which is autostreamer.live. Link will be in the description too. You can also visit a sample website it is created. Here is a Python course that was created in that live stream.
Collections module.
So at the end of its process, it actually creates this website, which you can deploy, which I have at Railway. And at the end of the video, at the end of the live stream, I actually show how you can deploy AutoStreamer generated content. Another one of my popular apps is CodeHive.app, which features over 900 GPT-powered Python applications. You can simply browse through it. And if you see something you like, just click on it. And here is the code that'll make it run. You can copy paste and experiment with it, get inspiration and find maybe business ideas and experimental playgrounds. If you do like this concept, you can actually download all of the code from my Patreon, currently for $100. I've also created some free apps, fastpython.app.railway.app, which will be in the description. It's a very cool click and learn interface for learning Python. You can refresh topics to get new ones. You can continually refresh topics to get new and interesting topics at any level that you're looking for, and continually just learn new stuff, at least as in the brief. Another cool app I recently built, which is online and is free, is llm.tldr.app.railway. We'll put the link in the description, which retrieves the latest 10 large language model related archive papers. And you can find the URLs to go visit or click on any one of them. And this will actually summarize it and create a quick audio so you can stay on top of the latest developments about large language models. Here we go.
In the paper, time series through experiments on.
Thank you for watching, and I will see you in the next video.